In this video, I am going to solve the problem 29th from chapter 17, Waves Part 2. A state trooper chases a speeder along a straight road. Both vehicles move at 143 km per hour. The siren on the trooper's vehicle produces a sound at a frequency of 915 Hz. What is the Doppler shift in the frequency heard by the speeder? So what they mention in the question, you have to see the figure. Two vehicles are mentioned here. One is a speeder vehicle and the second one is the trooper vehicle. And here the trooper is chasing the speeder, and both vehicles are traveling or moving at the same speed of 143 km per hour. And this trooper vehicle produces a sound at a frequency of 915 Hz. That means here the trooper vehicle is nothing but a source because it is emitting the frequency, am I right? From the siren, it is producing the sound, and that sound has the frequency 915 Hz. So here the trooper vehicle is considered to be a source. Clear? So if this trooper is source, who is the detector? The speeder vehicle is the detector, right? So I will write detector here. Okay. And this trooper vehicle is emitting the frequency which is F 915 Hz. And both vehicles are travel at the same speed or move at the same speed. That means the speed of the source is 143 km per hour and the detector speed is also 143 km per hour. So we have to convert this kilometer per hour in terms of meter per second. And what we are going to find from this question, we are going to find what should be the Doppler shift in the frequency heard by the speeder. That means we are going to find what should be the value of f dash. Here f dash is nothing but the frequency heard by the speeder. So before that, I have to convert this kilometer per hour in terms of meter per second. Let's we convert this kilometer per hour in terms of meter per second. So 143 kilometer per hour. In 1 kilometer, we have 1000 meter, right? Likewise, in 1 hour, we have 3600 second. How we got 3600? 60 multiplied by 60. 60 seconds, 60 minutes in 1 hour, right? So by that, we can easily cancel this kilometer with kilometer. Likewise, we can cancel this hour with hour. Now, the answer what we are going to get is in terms of meter per second. So 143 multiplied by 1000 over 3600, I got the answer as 39.72 meter per second. That means here I have to write the value in terms of meter per second. So the source speed in terms of meter per second is 39.72 meter per second. Likewise, the detector speed in terms of meter per second is also the same value, 39.72 meter per second. Clear? Now we have to frame the formula for getting the answer for f dash. So generally, both vehicles are move at the same speed. So the frequency emitted by the trooper will be the same for the frequency heard by the speeder, right? Am I right? So we are going to prove that by applying the rule. So we have to prove everything by substituting the value in the formula. Clear? So for that, I am going to write the general formula for the Doppler shift, which is f dash, which is equal to f multiplied with v plus or minus vd over v plus or minus vs, where f dash is the frequency heard by the speeder, where f is the frequency emitted from the trooper vehicle, and vd and vs is the speed of the detector as well as the speed of the source. And here the v is nothing but the speed of the sound in the air. Generally we consider that value as 343 meter per second. Clear? Now I have to frame the equation because here if you see the general rule, we have plus or minus in the top as well as the plus or minus value, the sign in the bottom. So we have to choose only one sign in the top and one sign in the bottom. So for that we have to identify the case what is given in the question. So what I'm going to do now, I'm going to write the formula without sign. So f dash, which is equal to f multiplied with v vd over v vs, right? Okay, now I'm going to the figure. So let's we see what is the sign in the top as well as the bottom. So let's we start with the denominator. What is the denominator? What sign will come here? V dash vs, am I right? So we are going to write what sign will exactly come in the bottom. So generally, if the trooper is chasing the speeder, that means the speeder is going to hear the frequency more, right? So if you want to get a more frequency, positive sign will not work here, because if you put positive here, the denominator will be greater. By that, the answer what you are going to get will be the smaller. So that means the sign in the bottom should be a negative, right? Clear? Okay. Now we have to come for the top. You have to see the figure. This speeder is going away from the trooper. Am I right? He is not going towards the trooper. He is going away from the trooper. In the theory we studied, if the detector is moving towards the source, it will have the positive value in the top. If the detector is moving away from the source, it will have the negative value. So here, as per in the figure, the speeder is going away from the trooper. So that means the sign in the top will also be a negative. Clear? Now I'm going to substitute the value. So better I will write the value here. So the frequency emitted by the source here is 915 hertz, and both vehicles are moving at the same speed. That means Vd and Vs will have the same value as 39.72, right? 39.72 meter per second. Now, and the speed of the sound in the air we already wrote, which is 343 meter per second. So I'm going to substitute the value. So f dash, which is equal to 915 hertz multiplied with the speed of the sound in air is 343 minus 39.72 over, in the denominator also we get 343 minus 39.72. By that, the top and bottom will get cancel each other, right? So here we will get the answer of f dash as same like f, right? Clear? So why we got the same answer? What is the reason? Because both vehicles or travel or move at the same speed. That's the reason. Clear? So this is the answer for this question. Thank you.